Morning, everybody. So this is the day 2 video. I'm actually shooting this on the Tuesday before Christmas, and I'm at school, and there's no one here except me and a few other employees, and it's really kind of creepy without all the chatter of the kids. So I'm going to get this video done as quick as possible because I want to get out of here because it's a little creepy. I want to start by doing some of the homework problems from last night. This was number 11. If we're looking at this, again, we're doing elimination. So what we're trying to do is we're trying to eliminate a variable. If we look at this, we want to see if any of the variables have matching coefficients. And it looks like the 10x does, and it also looks like the y's also have 2's in front of them. So we're ready to go for elimination. We can just go right at this. So we'll put our line down. And these have negatives, so I don't really want to think about these yet. I like thinking about the positive stuff, just makes it easier for me. So I'm trying to think, how can I get 2y away from 2y? How do I eliminate this variable? It's going to be subtraction. So let's think about this. I'm going to do negative 10x minus negative 10x. That's negative 10x minus negative 10x. Don't be afraid to ever come write an additional step so that you guys make sure you get your math right. This is going to clean up to be negative 10x plus 10x. Negative and a negative make a positive. Therefore, this is going to be 0x. 0x. Next, I'm going to do 2y minus 2y. Again, you want to touch the operation every single time. Just make sure you're going to do it right. So 2y minus 2y is going to be 0y. And lastly, we have negative 7 minus negative 2. That's negative 7 minus negative 2, or negative 7 plus 2 is going to give me negative 5. We don't usually write zeros or zeros with variables, so really this is saying that we have 0 equals negative 5. And that turns into one of our special situations in which the variable's eliminated and we got a false statement. 0 does not equal negative 5. Therefore, since we have a false statement, this is going to be no solution, because we're looking at a set of parallel lines. Okay, that's the instance for number 11. Great, let's go ahead and do number 12 next. Okay, this is number 12 from last night's homework. Again, the name of the game here is we're trying to eliminate a variable. So we're going to look across. Do the x's have the same coefficients? Yeah, they both got a 2. Do the y's have the same coefficients? Oh yeah, they both have a 5. So we could choose to eliminate any variable here. Since x came first, I'm just going to eliminate x. And I'm going to think to myself, how can I make this into a 0x? 0x. Let's see. So if I add negative 2 and positive 2, I'm going to get 0. So it looks like the operation I'm choosing between addition and subtraction this time is going to be addition. So now I'm going to go through. I'm going to say negative 2 plus 2x. That's 0x. Again, if you need to write that out, do it. Negative 2x plus 2x. And again, that gave me 0x. Next, you'll have 5y plus negative 5y. So 5y plus negative 5y. That's going to give me 0y. And lastly, I have 7 plus negative 7, which also gives me 0. If I clean this up, I'm looking at a situation where I have 0 equals 0. My variable is eliminated, and I have a true statement at the end. 0 does equal 0. So this is, again, one of our special situations, which is over on the board to the left. And this is going to be infinite solutions. We're actually looking at the same line here. Okay, great. Let's do some more. Okay, here's the first example that should be going in your guys' notes today. Here we're looking at an equation or a system where we have 2x minus y equals negative 1, and we have x plus 2y equals 2. Now, you could do this through substitution, Again, you could take this guy here and you could solve for a variable. So we'll solve for x. You would get x equals negative 2y plus 2. And now that we've solved for x, we can take this and we can substitute it in like so. And we could go through our normal steps of substitution. But now what if you're sitting here saying, well, I learned this new skill, elimination, and I like it way more than I like substitution. Well, there's something we can do to actually eliminate here. If we look across, we're like, do the x's have variables that match? Or sorry, coefficients that match? No, they don't. Do the y's have coefficients that match? No, they don't. So we can't look at this right away and do elimination. But what we can do is we can manipulate this stuff. We can change it so that we can do elimination. So if we want to look here and we want to say, look at this this pink equation and look at the x's, all right? This has 2 x's, and this only has 1. And the question is, what can we do to the pink equation to make it so that it has 2 x's? And the answer is we can actually multiply this. So let's rethink of it like this. Let's do a times 2 to the entire thing. So that's going to be 2 times x plus 2y equals 2. Again, if we're going to multiply on the left, we have to multiply on the other side of the equal sign also. So I'm just going to multiply everything, the whole pink equation, by 2. That's going to give us a new pink equation. This new pink equation now is 2x, right? There's my first distribution, plus 4y. I like arrows. There's our second distribution. And let's get the one on the other side of the equal sign. This will equal 4. Again, I've done the whole pink equation multiplied by 2. That's now given me a new pink equation. So let me bring the blue equation back over. 2x minus y equals negative 1. And by doing this multiplication of 2, I've set this system up for elimination. So now I can go through my normal steps. I'm going to draw my line under and choose, am I adding or am I subtracting? How am I going to get 2x, or how am I going to get these x's to eliminate? I'm going to subtract. And again, I'm going to touch my operation every single time. So it's going to be 2x minus 2x is 0x. Now I'm going to have negative y minus 4y. This will give me a negative 5y. And this is going to equal negative 1 minus 4. Negative 1 minus 4 is negative 5. I'm going to keep working with this algebra here. I'll bring it down right here. You have negative 5y equals negative 5. I'm going to divide by negative 5 on both sides. This will give me that y equals 1. Now that I know that y equals 1, I'm going to take it, I'm going to substitute it into one of the equations. Let's say the blue one here. I'll even go to blue. You're going to have 2x minus y, which we know is 1, equals negative 1. So we have an instance where we have 2x minus 1 equals negative 1. I'm going to start solving for x, so I'll add 1 on both sides. This will give you 2x equals 0. I want to get x by itself, so I'll divide by 2 on both sides. This will give me that x equals 0. So if I were to graph these two lines, they would cross at the point 0, 1. Okay? Again, the big step here, the new idea that we're learning is we are going to multiply one of the equations in the system so that we can set up the problem for elimination. Let's go ahead and do another one. All right, here's another system. This is example 2. If we look at this one's actually harder than the other one because we'd have to do a lot of manipulation to do substitution. Substitution looks pretty difficult here. Elimination, we're not set up for it, so it's one of those situations where we need to look at one of these equations and decide what can I multiply by to get a leading coefficient that's the same on one of the variables. And if we look at this, can we multiply 2 by anything to make it equal 3? Nothing simple. We can, but it would be difficult, and we want to choose the easiest way to do this. That's what mathematicians do. They try and find the easiest, simplest way to manipulate things. If we look at 2 down here on the blue equation, is there anything we can multiply 2 by to make it equal 8? And there is. That's a pretty easy multiplication. So it looks like we're doing a times 4. We want this -2 to equal 8. Or sorry, we want the 2 to equal 8. So we'll multiply by 4. So the blue equation multiplied by 4. Again, and we got to multiply the entire equation. I wrote it like this last time, but really what's going on is if we're multiplying the left by 4, we have to multiply the right on the other side of the equal sign by 4 also. Okay, so we're going to distribute here. And this is going to give us our new blue equation, which is going to be 8x minus 8y equals -40. Let's bring over our pink equation also. This is 3x plus 8y equals 7. And now that I've done this multiplication, I am set up for elimination. The y's both have 8s in front of them. So I'm going to go right at it. I'm just going to draw my line, and I'm going to decide how am I going to make +8 eliminate -8. That's going to be addition. So I'm going to add. And now I'm going to walk through each one. So 3x plus 8x is 11x. 8y plus -8y is 0y. 7 plus -40 is going to give me a -33. As I go through this, did I eliminate a variable? Yes, I eliminated y. Let's clean this up. I have 11x equals -33. To get x by itself, I'll divide by 11. This will give me that x equals -3. I'm not quite done yet, though. I need to figure out what y equals. So I'm going to plug this x into either equation, pink or blue, it doesn't matter. Let's say I plug it into the pink. It'll be 3 times -3 plus 8y equals 7. As I clean this up, I'm going to get -9 plus 8y equals 7. Let's keep getting getting y by itself. So I'm going to add 9 to both sides. So give me 8y equals 16. Last step, divide by 8. Y will equal 2. That means if we were to graph these two lines, we would expect them to cross at -3, 2. Again, we did this all by setting it up for elimination by multiplying by a factor of 4. Don't feel bad taking up space on your paper. There's a lot of steps going on here. And one way to get lost is by purely cramming it all into one small space and losing what equation's doing what and where you're going with the system. We really want to use as much space as we need to make sure we're staying organized. Another way to stay organized is by using colors. Feel free to grab colored pencils from the front if you need them. If you need time, go ahead and pause and finish up your notes. We have one more example to do. Okay, here's our last system of the day. We have a 2x plus 3y equals -1 as our pink equation. And we have a 5x minus 2y equals -12 as our blue equation. As we look at these, is there anything we can do to easily multiply one equation to make it so we can set up for elimination? As I look at this, it doesn't look like we have anything too easy to play with. I want to ask myself, can I do substitution? I can't do substitution because I have all these numbers in front of my variable, so it's not going to be easy to do substitution. So what can we do here? Well, on some of these problems, it turns out we might have to multiply both equations. If I want to eliminate x's, Okay, I got to think of a number. Okay, think of a number that both 5 and 2 will divide. The easiest way to do this is actually to multiply the top by the bottom number of x and multiply the bottom by the top number of the pink equation. Okay, what I'm really trying to get at is that 10 is the number, okay, that both 5 and 2 share. What that looks like is I'm going to multiply the pink equation by 5. So -1. And I'm going to multiply the blue equation by 2. By doing this, I'm guaranteeing I'm going to get a 10x on both the top and the bottom. You could do the same thing with the y's. Okay, I chose the x's this time, but you could do the same thing with the y's. What's a number that both 3 and 2 both divide? That number would be 6. Okay, so what that would look like is you would multiply the top equation by 2, and you multiply the bottom equation by 3. Okay, again, that would make a 6 in front of both the pink equation and the blue equation y's. Okay, again, what we're doing is we're multiplying both equations to set up for elimination. Let's see, if you multiply both, or if you multiply one side of the equation by 5, you're going to multiply the other side of the equation by 5. Okay, what this starts to look like is a new pink equation of 10x plus 15y equals -5. Okay, I multiplied the entire pink equation by 5. The blue equation now is 10x minus 4y equals -24. Again, that came from the manipulation right here of multiplying by 5 on the top and multiplying by 2 on the bottom. Now that I have x's that match, I can eliminate the x's. I'm going to draw a line under, and I'm going to ask, how can I get 10x to eliminate 10x? The operation I'm going to choose between addition and subtraction is going to be subtraction. I'm going to say 10x minus 10x is 0x. 15y minus -4y is going to give me 19y positive. Lastly, -5 minus -24, -5 minus -24 is going to give me positive 19. This is -5 plus 24. It'll be positive 19. Okay? So now that I've eliminated a variable, I'm going to solve for y. This is 19y equals 19, or that y equals 1. But I'm not quite done. Still got to figure out what x equals. So I'm going to plug it into the pink equation. So I'm going to have 10x plus 15 times 1 equals -5. This is 10x plus 15 equals -5. Going to keep solving for x. So you're going to have you're going to subtract 15 on both sides. So 10x equals -20, or that x equals -2. So if you were to graph these two equations, you would expect them to cross at -2, 1. Okay, so that's the new skill, and that's what you're going to practice in homework tonight, is you're going to be multiplying one of the equations first to set up for elimination. I felt I might have gone a little fast or kind of stuttered a few times during this video. Feel free to watch it again, or let me remind you that I am not the only one that has made videos like this. You can find the skills you are practicing in class on YouTube by a lot of different teachers and by a lot of different programs such as Khan Academy. I hope you guys are having a great day. I will see you on Friday if you want to come say hi. Otherwise, I will see you all on Monday. Make sure you finish your elimination homework, and make sure you finish your elimination packet. Besides that, we'll talk to you guys later.